Right, exercise 13.04, we're just going to try 1e here, which is slightly more challenging. Okay, so z equals -1 plus root 3i to the power over 3 over 2. Now it's not as easy as the other ones. For a start, I'm not 100% sure how many solutions I'm looking for. The other ones all had whole numbers here. We've got a fractional power. We can use the same method, but we just might have to do it the long way. Step 1 is to write the complex number in polar form. So if we just have a look at that over here, and yes, you can use the calculator as well to check. -1 plus 3i plus root 3i. So there it is up there, complex number. Now this triangle looks like one of the special triangles that we looked at briefly the other day. 1 root 3 2, with this angle being 60 degrees. And you can have a look on your formula sheet, you don't have to remember that triangle, but it's there. Now that tells me for a start that the modulus is 2, so that's easy straight away. That angle is 60, which would make that angle 120 that I've used for the complex number to write it in polar form. So I can see that z equals 2 cis 120, and we're raising it to the power of 3 over 2. So de Moivre's theorem. Now what we might need to do this time is take, because we're not absolutely certain how many solutions there are, distinct solutions, we might put in the counter that we talked about the other day, and we'll write this as 2 cis 120 plus 360n. You might need to look back at your notes to just remember why it is we put the counter in. N takes the values of 0, 1, 2, 3, the number of times around the circle. So z1 will be 2 to the power of 3 over 2 cis. Now we need 3 over 2 times the 120 plus 360n. z1 equals, there might be a nicer way to write this. 3 over 2, the top number of course is the power and the bottom number is the root. Square root of 2 is not nice, but we can do 2 to the power of 3. 2 to the power of 3 is 8, and then square root that. So I know that that's the same as the square root of 8. It just looks a bit tidier. Now we need 3 over 2 times 120, and that equals 180, plus 3 over 2 times 360 over n, which gives me a big number like 540n, which isn't looking very promising, so we'll just have to see whether that's going to give me what I want. Now we start substituting values for n. So if we let n equal 0, I'll get z1 equals root 8 cis, and 0 in there would give me root 8 cis 180. So that's one possible solution. Substituting n equals 1 for the second solution gives me root 8 cis. Now n is 1, 540 times 1 plus 180 is going to give me 720, and you can check that on a calculator. Now that's very big, I can tell, and 720 actually would be twice around the circle. So this is actually the same as root 8 cis 0 for another solution. Right, we'll keep going and see what happens. So let's try n equals 2 for the third solution, if there is one. So we need 3 times 540 plus 180, a gigantic number like 1260. And I'm wondering to myself how many times round the unit circle 1260 is. And a quick division by 360 shows me 3.5 times, so actually I'm back to the solution of root 8 cis 180. So there only appears to be 2 distinct solutions. That's one solutions, and that's the other one. And of course root 8 can be written as the square root of 4 times 2, so we can write that as 2 root 2. You might notice in the answers that that's written as 2 root 2. and we can see we've got 2 solutions. So this is a good reminder of using the counter method if you're not totally sure how many solutions there are.